So in this video, we're going to discuss thin layer chromatography, which you have probably done before in another class, but I really encourage you to pay attention here, as there are some things we're going to have to do differently, sometimes a little more analytically carefully than what you have done in the past. By far the most common type of plate used in forensic chemistry and toxicology is going to be a silica gel plate, similar to the one shown here. The dimensions may vary, and it may or may not have a fluorophore added to it. In the case of this plate label, you see that F254 indicating that this has a fluorophore added to it. That fluoresces at 254 nanometers. When you have plates that have these fluorophores added, that means that you can use the UV light to preliminarily look to see where your spots are. If there is no fluorophore, you can't use the UV light and you have to go to some developing agent. But you can also use developing agents on plates that do have fluorophores in them. There are certainly other media. Alumina is quite common, and there are several others, but you're really not going to see those used too often in forensic chemistry and toxicology. It's going to be almost exclusively silica gel. On any day that you think you might be doing TLC, I encourage you to, first thing when you come into lab, get your chamber set up. And this is going to mean have your chamber ready and clean, and pour in whatever mobile phase you're going to use for the experiment. You need this chamber saturated, and that can often take 30 minutes, and you want that process, you need it saturated before you run your plate. And it's nice to have that done when your plate's all ready. So if you just start it as soon as you get into lab, by the time you're ready to run your plate, it's all set up. The most common solvents that we use as mobile phases are going to be the systems in Clark's analysis of drugs and poisons called Clark's TA, which is a ratio of 100 to 1.5 methanol ammonia, and Clark's TB, which we will likely be using for this lab, and that's a ratio of 75 to 15 to 10 cyclohexane toluene diethylamine. Clark's TC is also run sometimes. You see it there. There are some other systems listed in Clark's, and it can be a good idea if you're looking for a particular drug to go look up in Clark's what the RFs are for that drug in different systems to give you an idea of what systems it runs in and what systems it just sits at the origin. Once you have your solvent in place, you want to saturate the chamber. One thing that really helps with this is taking a piece of cut filter paper and sticking it on the back wall of the chamber, and this soaks up solvent and helps to fill the chamber with fumes. That's what we're talking about when we say a saturated chamber, is we want a chamber very humid with your solvent fumes. So once you've got this guy closed, you're going to leave it for typically 30 minutes or more, and then you're going to try to open it as little as possible. You're going to preserve that saturated solvent humid chamber. In these types of chambers, I like to cut a piece of filter paper and sort of circle it around itself, and then insert that into the chamber and allow it to sit on the back wall. Now notice I've showed you two types of chambers. Those are the most common. Notice what I haven't showed you is a setup that you may have used before, where you just sort of set a watchglass on top of a beaker. That's not really sufficient. You need a nice TLC chamber that has a really good seal. So you can't just set something on top of a beaker. You need a real tightly sealing proper TLC chamber. Once you've got your chamber going, that's the first thing you want to do. You're going to get your plate ready. Now there are several different styles of plate that I'll show you. These are going to be the ones that we will likely be using in this lab. You can sort of use a double to get twice the width there, as you've seen, or the single there. Now I'm going to show you how a good strategy for marking your origin on actually a much larger plate. We have these two, and you can use a large chamber for them. So you need to mark off your origin at a height that you know is going to be above your solvent level on the chamber. Do it carefully. You're trying to damage the silica as little as possible, and draw your origin line straight across. Again, this needs to be high enough that it does not go into the solvent. Sometimes I like to mark off spots where I plan to add sample. You can get a lot of samples on these wider plates. You can typically get 3, maybe 4 if you're very careful on the smaller plates. When you're spotting the plate, it's really important to be patient and take your time. You're going to want to make as small a spots as you can, but put a lot of material on that spot. and that can be a little frustrating. So I use these little pipettes and these micro glass capillaries. You draw up a little bit of your solution, and then you're gonna draw up the solution. You're gonna touch it to the origin on your marked spot, and again, you're trying to make as small a spot as you can. The spot is gonna want to spread out, so you just put a little bit down, and then you wait for that spot to dry. That part is boring. You wait for the spot to dry. All right, if you make your sample an acetone, that'll help things dry up a little bit faster. And then after that spot has dried, you're going to spot it again and again. If you just spot it once, depending on the concentration, you're probably not going to see results. And if you don't see results, one of the first things that we're going to sort of consider is, did I spot enough material? So small spot with a good amount of material is what you're sort of hoping for. And it can be a little frustrating. It can take a little bit of time, but have patience. Keep your spot ideally 1 millimeter or so, maybe up to 2 millimeters. You should be able to pretty easily fit 3 spots that aren't anywhere near touching each other on these narrow plates. And if you're very careful, sometimes you can get 4 spots. When you place the TLC plate in the chamber, leaning against the wall, if the solvent, this is heartbreaking, but you have to get rid of it if the solvent, if it goes in and the origin is in the solvent. So if you put it in and the origin is in the solvent, you really want to pull the plate out and get rid of it and start again, because that'll wash your stuff away and you won't get anything. So be careful putting it in, and make sure that you put your origin high enough that the origin isn't down in the solvent. All right, the solvent needs to wick up to the origin and then pass that. When the sample's done, you're going to take the plate out, and again, here you must have patience. Let the plate dry in the hood completely. Take the plate out, get the dripping stuff off of it, and then set it on something with the silica side up and let it dry completely in the hood. Your development, or that is to say, the visualizing the spots, is going to be severely hindered if you do not let it dry completely in the hood. The easiest way to begin visualizing your plate, if it has that F254, if it has a fluorophore in it, is to visualize it with a UV light at 254 nanometers. Some of these lights, you need to make sure it says 254 nanometers. If it has the option for both short and long wavelengths, the 254 is usually the short, and if you put it on the long, it will not work. So if you're trying to see your plate under UV light and you're not seeing anything at all, one of the first questions you want to ask yourself is, am I in fact using a 254 nanometer centered wavelength light, or am I using the wrong color or the wrong wavelength UV light? The object when you're looking at this guy under UV light is first to just see what you're going to see by holding the light, but then if you want to present this data, you need to present it as a photograph. All right, that is the actual data. It's going to be a photograph of the data. Do not circle the spots. Do not circle the spots. We are not very interested in RF values. We don't really care that much. You can use RF values to help you decide what it is, but our data is based off of comparison with standards, with positive controls. So don't circle them and don't turn in an RF value. You're turning in a picture that should have your sample in comparison with a positive control. Any data that you're turning in should be well labeled. So I've put some labels here indicating that in that first lane, I've got my lidocaine standard. And in the second lane, I have sample 1, and the third lane, I have sample 2. Now, if I'm going to use shorthand labels like sample 1 and sample 2, then this figure, if I was putting it in a report, needs to, below the figure, have the caption where it defines explicitly what sample 1 and sample 2 is. I can't just write extraction 1 and extraction 2 and assume that the reader and ultimately the jury will know what that is. And all the data needs to stand on its own. You can't pretend you're standing behind me, or if I say I couldn't exactly understand what this is, what I'm really thinking in my head is a jury or an attorney looking at your report would not know what you meant by this. It's not well enough defined. And it's not good enough to sort of stand over their shoulder and say, I meant this, I meant that. Your data has to stand on its own. So everything has to be well labeled, and any sort of shorthand indicators you give, like in this case sample 1 or sample 2, needs to be explicitly defined close to, really in the caption of that figure. Along those lines, the data needs to be obvious. It needs to be apparent. And this can be frustrating sometimes with TLC, because you'll be in the room in the dark and you're like, I can see it with my eye. I think it's there. But you have to look at the quality of your reported data. In this case, the quality of your image. If it is not apparent in the image, it's not good data. So if I was doing this data, I would be encouraged, because that spot there in my lidocaine standard indicates that is the spot for lidocaine in this run in this system. And then right next to it in sample 1, I do in fact see the same spot at the same place. So this data is encouraging, and if I was doing an extraction to pull lidocaine out of sample 1, I would say, well, I think I got lidocaine, but there's a bunch of garbage sitting there at the origin. And then also, those spots are very faint. This is not great data, even with the standard. If you were going to do this again, you would want to spot it more heavily or use a higher concentration of lidocaine. Now, when I say spot more heavily, it doesn't make big giant spots, because they're going to spread out anyway. It means spend more time, spot, wait for it to dry, spot it again, wait for it to dry, spot it again. And that'll get you darker spots up top. Another alternative is this fluorescence method is not very sensitive, and you can use visualization agents to see things better. And I'll show you in just a minute, iodoplatinate, the most common one. Another issue I want to point out with this data is that here I ran a lidocaine standard, or the positive control that I was interested in, lidocaine, sample 1 and sample 2. But I've made a mistake here. I have my positive control. I do not have my negative control. And in every bit of data you want to turn in, with rare exception, the biggest one being FTIR, you're going to turn in a positive control. You're always going to turn in a positive control. And you are almost always going to turn in a negative control. Usually if you're dealing with a solution, the negative control is just the solvent in a solution. So in this case, I had my lidocaine standard, my sample. They were in methanol. So in place of that spot that says sample 2, what I should have done to make this complete data was spot just the methanol I was using as a negative control. And if you get a really nice spot for your standard, your positive control, and your sample indicates the same spot, it's a good looking spot, and your negative control doesn't have anything, ideally at all, but definitely where that spot is for the standard, then that's good data. Good positive control, good sample, good negative control. So if you want to try and get more sensitivity, or maybe a little more specificity or selectivity than fluorescence involves, you can spray on a visualization reagent. So you pour that in this container, you put on these aerosol tops we have, and then you can spray down your plate with the visualization agent. The most common visualization agent we're going to use is called iodoplatinate, and that's just going to react well with a lot of different amines. It's a pretty generic one. That's what I'm spraying this plate down with. But if you want to try something else, if you see something on Clark's that you want to try, I will try to find the ingredients for you and make it up. We've had students do that in the past. There's Van Erks and Dragendorf, a bunch of other ones that you can try that act as sort of color tests in the sample, and oftentimes can give you better sensitivity or be more specific for the thing you're looking for. So here is that same plate we looked at before, but this time sprayed down with iodoplatinate. And if we look at that in comparison with just the fluorescence, you can see that you get much better contrast when we've used the iodoplatinate. That's generally going to be true. Now, if you don't need it, there's no reason to spray it if you get signal just fine off the fluorescence. But you need to make sure that you have good contrast, obvious data that you don't have to stand there and explain to people. Your report must stand on its own. Now make sure that you look at it with fluorescence before you spray it down, because once you've used some sort of colorimetric reagent, it's permanent, it's done, and you can only use one. You can't say, oh, I want to use iodoplatinate and then use Van Erks and then use Dragendorf. Occasionally there are these very intricate sequences that can be piled onto each other, but in general assume that once you've sprayed it with something, it's done. That's the end of it. and make sure you take good pictures when it's done, because sometimes those colors and things do fade or change. So pictures are your data. Make sure you have good ones that stand on their own. You can also immerse a plate in a reagent. There's a really excellent reagent called the Marquis reagent that gives different colors for a lot of different drugs. It's quite dangerous, actually. I really should be wearing a lab coat here, and you see I've got the Marquis reagent and just some water. And when I immerse this plate, it's going to give a color indication. So that not only provides you with where the spot is, but the color of the spot can give you some information about the identity of the molecule. Sometimes it depends on the drug. So you can use color tests on TLC plates as well. Note that because the Marquis is so dangerous, I'm soaking in a little bit of water before removing it. Again, I definitely should be wearing a lab coat here, and I'm absolutely working in the hood. If you want to do something like this with a color test, that's fine. I'll try to get you the ingredients to make the color test. But check with me before you start making bunches of this stuff. Or actually, you won't make the Marquis. If you want the Marquis, I will make it for you. But before you start trying to use this stuff, check with me. We'll talk about it. And if it's appropriate, then we will get you set up to do that.